All right, now that we know how to simplify rational expressions, we're going to look at multiplying and dividing rational expressions. And what I want to do is I want to go back to basic fractions to talk about how we multiply those, because we're going to see that there's something similar going on here. So let's take a look at 2/5 times 15/8. There are two different ways that we can multiply fractions. We can multiply straight across and then reduce, or we can cross cancel. And most students tend to prefer to cross cancel. And this is going to be the best method when we're dealing with rational expressions. So I want to go through this one example first, and then we'll see how this applies with rational expressions. Now notice that the 2 and the 8 are both divisible by 2, so we can reduce those by a factor of 2. That leaves us with 1 and 4. Similarly, the 5 and the 15 are both divisible by 5, so we can reduce that by a factor of 5, giving us 3 and 1. And once we've reduced, we can multiply across. 1 times 3 is 3, 1 times 4 is 4, and that is our final answer. We're going to use a similar method when we are multiplying rational expressions. It's just going to be a little bit more involved. Let's look at an example. We'll start with x minus 3 over x plus 5 times x squared minus 25 over x squared minus 3x. This is a product of rational expressions, and even though they're rational expressions, they're still fractions, and so we can still cross cancel. But the thing that we have to do is we have to factor each of these so we can find factors that we have in common that can be cross-canceled. Now, x minus 3 and x plus 5 do not factor. However, the other polynomials do. X squared minus 25 is a difference of squares. We can factor that as x plus 5 times x minus 5. And x squared minus 3x has a GCF that can be pulled out. We can pull out the x, and that gives us leftovers, x minus 3. Now let's see what we can cancel. There's an x minus 3 that can get canceled in the top and bottom. And also there's an x plus 5 that can get canceled in the top and bottom. Once we cancel those, we're left with just an x minus 5 in the top and an x on the bottom, and that is our final answer. So whenever we're multiplying rational expressions, the goal is to first factor and then cancel. That's really all we're doing here. And in fact, that's what we did when we were simplifying rational expressions. We factored the top and bottom, and we canceled anything that canceled. The same is true when we're looking at multiplication problems. Let's do another example, and then we'll look at a division problem. Let's multiply 4x minus 4y over x times x squared plus xy over x squared minus y squared. This might seem intimidating in first because we've got more than one variable, but we can still factor and then cancel. If we look at 4x minus 4y, we can pull out a GCF of 4, giving us 4 times x minus y all over x. And then in the second fraction, we can pull out an x in the numerator, giving us x times x plus y. And then in the denominator, we have a difference of squares. That factors into x plus y times x minus y. Now that we've factored all of the polynomials that can be factored, we can cancel any common factors that we have. There's an x minus y in the top and bottom that can be canceled. There's an x plus y in the top and bottom that can be canceled. And there's an x in the top and bottom that can be canceled. And all that we're left with now is that 4 in the numerator. So this ends up giving us 4. Sometimes when we're multiplying or dividing rational expressions like these, we end up with just a constant in our answer. Now that we've looked at multiplication, I want to look at one division problem. Let's do x squared minus x minus 6 over x squared minus 16 divided by x plus 2 over x minus 4. Now, we have divided fractions before, and we know that when we have one fraction divided by another, we can change it to a multiplication by flipping the second fraction, and that's exactly what we're going to do here. This becomes x squared minus x minus 6 over x squared minus 16 times x minus 4 over x plus 2. Once we've changed this into a multiplication problem, we can do it just like the previous problems by factoring and then canceling anything that the top and bottom have in common. So let's factor. X squared minus x minus 6 can be unfoiled. We need two numbers that have a product of negative 6 and a sum of negative 1. And those numbers are negative 3 and positive 2. In the denominator, we have a difference of squares. X squared minus 16 can be factored as x plus 4 times x minus 4. And then the other rational expression can't be factored at all, so we leave that as x minus 4 over x plus 2. And at this point, we have some canceling that we can do. We notice that there's an x minus 4 in the bottom and the top, and also an x plus 2 in the top and the bottom. So we can cancel those out. And once we've done that, we're left with x minus 3 in the numerator and x plus 4 in the denominator. So the only difference when we're doing a division problem is that we have to change it to a multiplication by flipping the second fraction, and then we can continue with our factoring and canceling. These are just some basic examples of problems involving rational expressions. It's very important that you click on the link below and watch some of the other videos of example problems, because some of those are going to use the AC method and even factoring by grouping. So just looking at these 3 examples isn't enough to prepare you for the variety of problems out there. Make sure you've looked at several examples and you feel comfortable with all of them.